This is the simple assembly code to demonstrate direct map and set associative catches. So let's understand the code a little bit so that we can understand the catches easily. Okay, the offset here start from 0, 004, 008. As I mentioned earlier, that PC equals to PC plus 4, and normally PC start with the offset 000. Okay, so after PC plus 4 it's going to be 004, 008 all the way, because each instruction is 4 bytes long or 32 bits long. Okay, so let's assume that R0 equals to some number. R1 start from 0, R2 start from 0 as well. So add R1, 1. That means R1 equals to R1 plus 1. R2 equals to R2 plus 1. Like this. And then BL adder. BL is branch and link. So it's going to call an adder function here, located at offset 030. So you can see that the offset is within one page, one virtual memory page, because I want to make it easier to understand. And then R1 will be added with R2 and put it into R0, and finally it will return with the BXLR instruction. So BXLR will return here to compare R0 with 10, and BLT is less than condition to check whether R0 is less than 10 or not. And if it's true, then it will jump back to the loop label here. Okay, so as you can see, this is pretty much the diamond here and some loop body. Okay, so it starts from the loop body and it jumps back to the loop body again if the R0 less than 10. So this is the true and this is the false path. Okay, so this is pretty much a do-while loop. Okay, and when the condition is false, so PC will be PC plus 4, which is 014 base 16. Okay, and we don't really care much about the next instructions. Okay, so it's going to loop for a while and then stop looping. Alright, and I will use this simple assembly code to demonstrate the mechanisms of direct map and set associative catches in the next slide. Okay.